Winter road maintenance presents a significant challenge for many regions, balancing the need for safe driving conditions with environmental concerns. The traditional method of applying salt to icy roads, while effective, comes with a host of negative consequences. This article explores the environmental impact of road salt and investigates alternative solutions that aim to keep roads safe while minimizing ecological damage. The problem with road salt. For decades, sodium chloride, NaCl, commonly known as road salt, has been the go-to solution for de-icing roads. Its effectiveness lies in the principle of freezing point depression. When salt dissolves in water, it lowers the solution's freezing point below that of pure water. This prevents ice formation on roads, making them safer for drivers. However, the widespread use of road salt has led to numerous environmental and infrastructural issues. Environmental impact: toxic to plants and wildlife, contaminates freshwater ecosystems, pollutes drinking water sources, degrades air quality, infrastructure damage, corrodes vehicles, damages bridges and water treatment plants, deteriorates road surfaces. Long-term effects: chlorides from road salt do not break down in the environment. Accumulation in ecosystems over time. Given these concerns, researchers and road maintenance authorities have been exploring alternative methods to keep roads safe during winter while minimizing environmental impact. Understanding freezing point depression. To comprehend the alternatives to road salt, it's crucial to understand the scientific principle behind its effectiveness. Freezing point depression. This phenomenon occurs when any substance is dissolved in water, not just salt. The presence of dissolved particles interferes with the formation of ice crystals, lowering the temperature at which the solution freezes. The extent of freezing point depression depends on the concentration of the dissolved substance. This principle opens up possibilities for various alternatives to traditional road salt. Alternative salts. One straightforward approach to reducing the environmental impact of road de-icing is to use different types of salts. While these alternatives still pose some environmental risks, they can be less harmful than sodium chloride in certain aspects. Magnesium chloride, MgCl2, more effective at lowering freezing point, requires less salt for the same effect. Used in states like Connecticut, still somewhat corrosive to vehicles. Calcium chloride, Al2, highly effective at lowering freezing point, dissociates into 3 ions, increasing effectiveness. Requires less raw salt for the same de-icing effect. The key advantage of these alternative salts is that they can achieve the same de-icing effect with lower quantities, potentially reducing overall environmental impact. However, they still contribute to soil and water contamination, albeit at a slower rate than sodium chloride. Organic de-icing solutions. In the quest for more environmentally friendly options, some road maintenance agencies have experimented with organic alternatives. These solutions often utilize byproducts from various industries, turning potential waste into useful de-icing agents. Sugar-based solutions. Byproducts from vodka distilleries or sugar beet processing. High sugar content helps lower the melting point of ice. Can be added to road salts to enhance their effectiveness at lower temperatures. Cheese brine and pickle juice. Utilizes waste products from food processing. Contains salts and other compounds that can aid in de-icing. Beet juice, rich in sugars that enhance de-icing capabilities, can be mixed with traditional road salt to improve effectiveness. While these organic alternatives show promise, they are not without drawbacks. Some communities have reported unpleasant odors from beet-based solutions, and certain organic byproducts may still contribute to ecosystem problems, albeit in different ways than traditional salt. Urea as a de-icing agent. Urea, a compound commonly used in fertilizers, has also been marketed as an eco-friendly alternative to road salt. Its advantages include water solubility and ability to lower freezing point, generally safe for pets and children, effective de-icing properties. However, urea also has limitations. Poor performance below -4 degrees Celsius 25 degrees Fahrenheit, can decrease dissolved oxygen in waterways, may cause algal blooms when it enters aquatic ecosystems. Relatively expensive compared to other options. Brine, a proactive approach. An innovative method gaining traction in winter road maintenance is the use of brine. This approach involves applying a liquid salt solution to roads before snow or ice events occur. Key aspects of brine application. Preventive measure. Applied before snowfall or freezing conditions. Prevents ice from bonding to the road surface. Reduced salt usage. Uses approximately 25% of the salt required for traditional de-icing. Significant reduction in overall salt application. Cost-effectiveness. Initial investment in equipment, tanks, pumps, spray trucks. Long-term savings due to reduced salt purchases. Some communities report overall cost reduction in winter road maintenance. Environmental benefits. Less salt entering the environment. Potentially reduced impact on ecosystems and infrastructure. While brine application requires more planning and infrastructure, its preventive nature and reduced salt usage make it an attractive option for many road maintenance agencies. Challenges and considerations. Despite the promise of these alternatives, several challenges remain in the quest for eco-friendly road de-icing. Effectiveness. Any alternative must be as effective as traditional road salt in ensuring driver safety. Cost. Many alternatives are more expensive than sodium chloride, which can be a significant barrier for budget-constrained municipalities. Infrastructure. Some solutions, like brine application, require new equipment and training. Climate variability. Different regions may require different solutions based on their specific winter conditions. Public acceptance. New methods may face resistance from communities accustomed to traditional salting practices. Long-term environmental impact. More research is needed to fully understand the long-term effects of some alternatives on ecosystems. Conclusion. The search for eco-friendly alternatives to road salt represents a critical intersection of public safety, environmental stewardship, and technological innovation. While no perfect solution has emerged, the variety of options being explored offers hope for more sustainable winter road maintenance practices. From alternative salts and organic solutions to preventive measures like brine application, each approach has its strengths and limitations. The ideal solution may vary depending on local conditions, budget constraints, and environmental priorities. As research continues and new technologies emerge, it's likely that winter road maintenance will evolve towards more environmentally friendly practices. This evolution will require ongoing collaboration between scientists, road maintenance authorities, and policymakers to balance safety concerns with environmental protection. Ultimately, the goal is to find solutions that keep our roads safe during winter, while minimizing the long-term impact on our ecosystems, infrastructure, and vehicles. By continuing to innovate and refine these alternatives, we can work towards a future where safe winter roads don't come at the cost of environmental degradation.